Todo mundo. Vamos iniciar, então, nosso evento do dia de hoje. Bom dia! Bom dia, Vietnã. Lembram-se do Robin Williams? Nossa escola de primavera. Vamos fazer algo muito interessante hoje. Vamos começar. Lembrem-se, ontem nós começamos a nossa escola de primavera com várias universidades juntos à Universidade de Salento, com a palestra do Sérgio, da Universidade. Lembrem-me, por favor, quais foram as pessoas que estávamos aqui ontem, Mônaco, França, muitas partes do mundo, o Brasil também está muito bem representado aqui, temos a Universidade Federal do Ceará e a Universidade Federal de Santa Catarina, do Brasil, muito bem representado. E a Universidade de Algarve, com a professora Esther Serrão e Rui Santos, muito bem lembrado, estiveram aqui, foi apresentações realmente extraordinárias. E também assistimos a um filme muito interessante vindo do Chile a respeito das kelps. E hoje nós estamos também muito bem. Desejo a vocês um ótimo dia, ótimas apresentações e desfrutem das palestras. Eu vou fechar a minha câmera agora, mas estarei aqui, atrás das câmeras. Obrigada, Paulo. Bom dia, meu nome é Giovana, sou uma estudante de mestrado em Oceanografia na Universidade Federal de Santa Catarina. Gostaria de lembrar-lhes a vocês que nós temos este ano 2 eventos juntos. O primeiro é a Escola de Primavera Austral de Fortaleza e a segunda é a Escola de Primavera de Floripa em Sustentabilidade. Nós vamos discutir hoje sobre carbono azul, corais, barreiras de corais, recifes marginais e sem
talks. I will present Dr. Martina Copari. She's a researcher and a lecturer at the Polytechnic University of Marche in Ancona, Italy. Her interests focus on the trophic and reproductive ecology of benthic suspension feeders, and she's also interested
in ecologia trófica. Então, Martina, a palavra agora está com você. Bom dia e boa tarde a todos. Meu nome é Martina Corpari e eu acho que vocês têm que me dar novamente a permissão para eu poder colocar os slides. Estão conseguindo ver a minha tela? Sim. Ótimo. Bem, então, em primeiro lugar, eu gostaria de agradecer o convite para esse evento e que eu posso, então, apresentar a minha tese de PhD e que foca na floresta animal marinha e também aspectos de biologia, de tecnologia, de diferentes espécies. Gostaria de começar com uma introdução breve. Animal florestais marinhos, diz respeito das espécies bênticas como corais, esponjas e gongônias, espécies que criam ambientes complexos e tridimensionais. A presença da floresta marinha define as condições do meio ambiente, especial a floresta, reduz a suspensão e aumenta a disponibilidade de alimentos, assim como a estabilidade do substrato. Por todos esses motivos, muitas espécies vivem associadas com essas florestas, encontram na floresta fontes de alimento e também vivem nessas florestas, utilizando a floresta como áreas de refúgio. Por esse motivo, os animais, florestas de animais marinhos têm uma alta gama de biodiversidade. E a maior parte desta biodiversidade é associada a importâncias comerciais e ao turismo. As florestas de animais marinhos dão suporte a atividades de pesca, também providenciando serviços de ecossistema para os seres humanos, devido à complexidade, à estrutura tridimensional.
Could support fishing activities, and therefore providing benefits for the humankind, the so-called ecosystem services. But due to the complexity and the three-dimensional structures and biodiversity associated, as well as the incredible colors of this environment, the marine animal forest could also support tourism and leisure and recreational activities such as diving activities or snorkeling, for instance. But another important and crucial ecosystem services provided by this marine animal forest is defined as blue carbon. And blue carbon is normally referred to the capability of coastal and vegetal environment to store and retain carbon in the sediment. And the definition blue carbon normally refers to particular environment ecosystems such as tidal marshes, mangrove ecosystems, or seagrass meadows. But recently, the terms blue carbon have been used also for other ecosystems, and marine animal forest could be one of these ecosystems. Indeed, the presence of the forest could increase the circulation of carbon and could modify the carbon flux, and the presence of the forest could be actively part of the Ventipelagic Coupling processes. And if you focus on this part of this picture, which this image represents the schematic view of the Ventipelagic coupling, you see here a mussel belt, which is an example of a marine animal forest. And the presence of this mussel belt being suspension feeder, the mussels could capture the particle present in the water column, and with their nutrient excretion, they fed the microbial food web, and at the same time, mussels during reproduction produce larvae or gametes that fed other organisms such as fishes or other pelagic organisms, and so directly support the trophic chain through different pathways, and participating in the Ventipelagic coupling, so connecting the two realms, the pelagic and the benthic realms. But a part of the carbon that is assimilated, that is provided by the food, is also used by the benthic organisms to increase in size and to directly build tissues or living structure, organic skeleton, etc. So we talk about carbon immobilization. And in this figure, in this image, you see a schematic view of how this carbon, how this flux of carbon could be immobilized in the benthic species. This is an example. This figure refers to a polar environment, but could also be used to explain the situation in temperate ecosystems. Indeed, in spring, after the algal bloom, there is also the zooplankton bloom, which is directly fed on algae, and both algae and zooplankton could reach the seabed and been eaten by benthic organisms, and this energy provided by both phytoplankton and zooplankton is used by benthic organisms to grow and to increase in size. And therefore, once this living structure in this tissue has been built, the carbon used to build the living structure is therefore immobilized for years, for centuries, or depending on the species, also for millennia. There is also another smaller portion of carbon that could be completely sequestered and buried in the sediment. And this is a smaller portion because the carbon, to be sequestered, the carbon should rapidly sink to the seabed and being quickly buried before being degraded by bacteria or by other organisms. So this is why this is a smaller quantity compared to the other. And I am going to focus in this presentation on this component of the carbon that has been immobilized, in particular in three different species of Gorgonian, three Mediterranean Gorgonian species. And I'm going to explain how this carbon invested for growth, so how how you could measure and estimate the carbon immobilization. So here I simplify the step that I performed to reach this estimate in these three Gorgonian species. So first of all, I selected the species, and I measure the carbon ingestion. You have to consider that the carbon ingestion could be either via autotrophy, which means that the organisms, Gorgonians for instance, as bacteria or algae as symbionts inside their tissues, and the symbionts provide energy through photosynthesis. But Gorgonians and filterfidens in general could also rely on the particles present in the water column for their provision of energy. In this case, we talk about heterotrophy. Some organisms could use both the feeding strategy, both the trophic strategies, and so we talk about mixotrophy. Of course, you have to consider both the components, both the feeding strategy, when you want to obtain an estimate of the carbon, of the total carbon ingestion. Then you have to measure the amount of carbon that is respired by the colonies and the carbon that is invested in reproduction for the production of oocytes, gametes in general, or larvae. To measure the carbon that is invested for growth, which is the real carbon that is immobilized and that could last for different years or centuries. So measuring the carbon for growth, invested in growth, is the easiest approach to estimate the amount of carbon that has been captured and immobilized. And you can estimate the growth of a colony or a species in general, either by photosampling. In this picture, you can see how the same specimen has been photographed in different time lapse, and so you can see how and how much it has been grown. And another approach to measure the growth of a colony could be through the photogrammetry. And photogrammetry rely on the construction of 3D models. And here you can see, for instance, that the red tips is the point of the colony that grow the most. Actually, this model is made in a sponges. It's not it's not made in a gorgonian. But I just put this video here to show how two different methodology could be used to reach the same objective, that is measuring the growth rate. And so here there is the publication about these 3 gorgonian species and the quantification of the blue carbon. This study was performed in the Cap de Creus area, which is in Spain and the northwestern Mediterranean Sea. And 3 species have been selected, 2, namely Leptogorgia sarmentosa and Paramuricea clavata, are completely heterotroph, which means that they are only suspension feeders. They rely on the particles present in the water column for their feeding. And these species have different habits and live in different could share the same habitat or could live in different communities. For instance, Paramuricea clavata prefer vertical and platform coralligenous assemblages to live, with Leptogorgia sarmentosa could live in coralligenous assemblages, but also in photophilic environment and also in detritic and coarse sand bottom. The last species that was considered in this study is Eunicella singularis. This species could live from 0 to 100 meter depth, but in this study we considered the depth range from 0 to 70 meter. And what could be observed is that this species is mixotroph from 0 to around 40 meter depth, and below this depth, this species is only heterotroph. So when you have to measure, you have to quantify the carbon ingestion for the shallower specimen, you have also to consider the contribution of the autotroph of the symbionts, the zooxanthellae that are present in the tissue of this species. Eunicella singularis mostly live in precoralligenous and coralligenous assemblages. So after the selection of the species, I made a literature review, and I found 15 publications that were useful for this purpose of quantifying the carbon immobilization, and I could obtain with this publication data on the carbon ingestion, respiration, the carbon invested in growth, and also data on the spatial distribution of these 3 species. If you consider that these species, these 3 species, are among the most well-studied species in the Mediterranean Sea. There are several publications related with the ecology and biology of these species, but data on the carbon invested for the reproduction, for the production of gametes and larvae is not available at present. So if this is the situation for well-studied species, you can already imagine what is the scenario for rare species or for deeper species where there is most of the data are still lacking. In this study, a methodology that is normally used in for the study of landscape ecology was applied for the study of marine animal forest. Indeed, remote sensing technique could be used to estimate the extension of land forest or crops, and in the same way, in marine ecosystems, you can use remote operated vehicles or ROV or autonomous operated vehicles to study the distribution of some species or entire animal forest, and also to reconstruct the seascape and the eventually the benthic cartography. And here you can see a detail of the Cap de Creus area, and gray bullets represent the 76 transects performed with ROV that have been analyzed by video analysis, and through this analysis, I could obtain the spatial and mathematical distribution of these 3 species, as well as their population size structure. But with ROV, it is also possible to estimate the amount of substrate that is suitable for the 3 species. For instance, if you know that Murisea clavata normally lives on vertical and platform coralligenous, you can estimate the hectares covered by this kind of assemblages through the assembling performed with ROV. So with this video transect analysis, we obtain also the benthic cartography of the area. And here you can see a flow chart summarizing all the steps that I performed to finally obtain a quantity of carbon, potential carbon immobilized by these 3 Gorgonia species. So if starting from the carbon flux that was measured by the difference from the ingestion and respiration rate, this carbon flux was measured first in all the colonies that have been observed in the video transect. For this same colonies, we also calculated the biomass, considering the ash-free dry weight per centimeter, and combining the biomass and the biomass of the observed colonies with the substrate available, the suitable substrate for all the colonies, I could estimate both the potential biomass and a potential carbon flux in the study area. In the same way, I measured the potential carbon immobilization. I started with the growth rate calculated in the observed colonies observed from the video analysis, and then I coupled this data with the potential number of colonies present in the study area, obtaining the potential carbon immobilization in the Cap de Creus area. Another another way, another method to obtain a large-scale quantification of the blue carbon is the use of the species distribution models, that are statistical models that are based on data on species abundance and environmental and topographic characteristics of the study area. Combining these two data, you can obtain a full coverage predictive map of distribution and also of abundance of the species. And if you combine the data obtained with this model with data of the carbon immobilization, you can also see in the map the areas that are that present the higher amount of carbon immobilized. So you can use this map, this predictive map, as a tool to protect and manage some areas in particular. And from the results of this study, I obtained that the carbon immobilized in this area by these three species is as high as 1.50 multiplied by 10 to the power of 2 tons of carbon per hectares per year. This quantity, if you compare this quantity with the carbon immobilization mediated by other ecosystems such as mangroves, Amazonian forest, and seagrass meadow, you can see that our gorgonians can immobilize 2 orders of magnitude less carbon than the other 3 ecosystems. But you have also to consider that here in this study we consider only 3 species in a real complex coralligenous community, and if we could also add data of the immobilization carbon mediated by the algae that create the framework of the coralligenous, or add the data of other sponges, other bryozoans, and in general the most abundant species that live associated with the forest, that live and create the forest, I am more.
Espécies que foram bem estudadas, são bem conhecidos, conhecemos a distribuição, sabemos muitos aspectos de sua biologia e ecologia, mas o que acontece com espécies que são mais no fundo do mar? Por exemplo, aqui coloquei alguns exemplos da minha pesquisa de pós-doutorado, do resultado da minha pesquisa de pós-doutorado, que eu foquei nessas espécies aqui do slide. Então, são de 40 metros a 160 metros de profundidade. Essas espécies criam florestas extensas e densas. Esses corais conseguem viver juntos com as gorgônias e conseguem criar florestas com diferentes características dos corais. Com múltiplos tipos de corais nessa floresta. Mas eles também podem criar florestas de espécie única. Então, considerando que eles podem dominar as comunidades mais profundas, mesofíticas, então seria interessante a gente ter informação sobre a quantidade de carbono imobilizado por essas espécies. Outra característica importante dessas espécies é a longa vida que eles têm.
Mobilized by this species. And another important characteristic of this species is the long lifespan. Indeed, Leiopathes glaberrima is one of the most long-lived species known so far, and in 3 studies. It has been dated the age of Leopates glaberrima, and 2 studies found that the species could live more than 2,000 years, and 1 study found that could live more than 4,000 years. So in this case, if we could know the amount of carbon that is immobilized by this species, we are also sure that this carbon is immobilized for millennia. And during my postdoc, I focused my study on the ecology, in particular, of this species, that is Antipatella supinata, which is the shallower black coral species in the Mediterranean Sea. And I just started to study some aspect of its biology, such as the diet that has been studied with the stable isotope analysis, and also I described some aspect of the asexual reproduction of the species, in particular through fragmentation, and also I described in aquaria the bailout phenomenon in this species. And what is interesting is that although these 2 asexual reproduction strategy has been observed only in aquaria, it is likely that this fragmentation or the production of bailout propagules could also happen in natural environment. So what could be the fate of this fragment? Imagine that if the fragment could immediately attach and start growing as fast as it happened in aquaria, it could immediately become a carbon immobilizer. But if in the natural environment the fragment is not able to attach as fast as in aquaria, it could be enter the Ventipelagic Coupling, eaten by other organisms, by bacteria, so entering the Ventipelagic couplings and circulate carbon again. And the same happened with bailout. Bailout is a process that happens in really stressful condition in aquaria, and it is the active detachment of polyps of one single polyp or several polyps that completely change their morphology, became ciliated and start moving. And what happened with these propagules? As similarly to the fragment, these propagules could immediately settle, adhere to a new substrata and became a new colony and be carbon immobilizer, or could be eaten by fishes or by other organisms entering the Ventipelagic coupling. So I focused also on black coral species just to highlight the problem that is behind the lack of data for species that are deeper or that are less studied, because there are logistic constraints to study these species, and because they are considered and so to conclude and to just give you some take-home message, I can summarize that marine animal forests may immobilize a high quantity of carbon in their living structure, and this carbon immobilization could last for years, centuries, or even millennia, as in the case of the black coral Leopates glaberrima. There is a urgent need to study the ecology of the species to understand their contribution as carbon immobilizer, and marine animal forest should be preserved to maintain the ecosystem service as carbon immobilizer, but also as to maintain the ecosystem service provision of biodiversity, fishing, the provision of the sustainment of fish activities, and tourism. We also need to restore damaged marine animal forest to recover their role as carbon immobilizer, and we also need to protect pristine marine animal forest, and also the unknown animal forest. And with unknown, I mean forests that we are just starting to study, but we still don't know how much they could contribute. And so in the mitigation of the carbon dioxide produced by anthropic activities. And with this, I concluded, and I really would like to thank you for your attention.
Thank you, Martina. It was wonderful presentation. Thank you very much. Now, I think we can follow. We will move to the Marcelo's talk. I'm right, Giovanna?
Yes, Marcelo did send you the
Yes, he did. Are you with us, Marcelo? Let's do it.
Yes.
So
Let's do it.
I will use this moment to reinforce the need to, well, please, put your brain to warm right now. Write your questions in our chat. Even in Portuguese, in the room in Portuguese, you can write in Portuguese. Você pode, então, escrever sua questão em português, que nós vamos fazer a tradução aqui, that we're going to make the translation here. So, no, I will present for you, of course.
Yes.
Can you introduce Professor Marcelo, Giovanna, please?
Sure. So, Professor Marcelo obtained his PhD in geological sciences at Autonomous University of Barcelona in Spain. And now he works as a teacher at Federal University of Ceará, coordinates a research group in oceanography, and our chief scientist in environment of the government of Ceará, gathering science with public policy and tropical marine environments like plastics, de Costa Semiárida of Brazil, and Braspor Research Network. His research topics include marine biodiversity, ocean and coastal conservation, climate change, coral reefs, and mangroves. So, Marcelo.
The floor is yours. So, yeah, I will be behind the cameras again.
Okay. Thank you, Giovanna, for the presentation. It's a great challenge to talk after Martina. She done a very nice talk, and this is my time now to do this work. First of all, I'd like to say some few words that I am very, very happy to participate in this international school. Especially, I would like to thank Professor Paulo Horta and Professor Sérgio Rossi for organizing this international school with many friends from Italy, Monaco, Cyprus, and other countries around the world. Okay, the sound and image is okay, Giovanna. If you have some problem, you talk to me.
No, it's fine.
It's fine. Okay. I will talk a little about the marginal reefs today, or if you can say extreme reefs. Okay. And next, Paulo. So, Martina talked about the marine animal forest. This is very interesting theme.
Isso é um tema muito interessante que no mesmo livro é mencionado. Aqui você pode ver nessa floresta um recife de corais com as características, as cores, os oxígenos, uma floresta muito interessante. E o professor Sérgio Rossi ontem falou sobre 2 livros muito interessantes, livros que ele publicou, que você pode ver na tela, sobre as perspectivas sobre diferentes florestas de animais marinhos do mundo. Uma das leituras mais... Um dos ecossistemas mais interessantes que existem no mundo são os recifes de corais. No mundo inteiro, nós temos barreiras de corais no mundo inteiro muito interessantes, especialmente nas regiões tropicais. Aqui você pode ver nessa linda fotografia um recife de coral típico e também algum professor como este que você vê, o Simpson, da universidade ou no colégio ou no ensino médio, podem definir um conceito de recife.
The coral reefs. Please, Paulo, next. And maybe this professor, maybe Professor Paulo Horta or Professor Sérgio Rossi or just me, talk that tropical coral reefs occur and thrive in clear, shallow, and oligotrophic waters with a narrow temperature range. This is the most simple and common concept to define the tropical coral reefs around the world. We call in this presentation this kind of marine ecosystem like a traditional coral reefs, okay? This is the most recognized concept around the world. Paulo, please the next slide. So, maybe Sergio talked yesterday and other guys will talk today and tomorrow about the cornerstone of the coral reef ecosystem. And of course, it's the symbiosis between the coral, the host, and the endosymbiont, that is the microalgae. To maintain and persist this partnership, it is very important that we have the optimal conditions, especially for the traditional coral reefs. And what are optimal conditions? We need to have low nutrient content, adequate pH levels, adequate light, of course, for the photosymbiosis, for the photosynthesis, especially of the microalgae, the water transparency, okay, and a lower SST variability. SST is the sea surface temperature. These are the optimal conditions. Optimal conditions for what? Please, next slide, Paulo. Optimal conditions, especially for the geoecological functions. Tomorrow, my friend from Mexico, Lorenzo Alvarez Filipe, will talk a little about this. He is a great expert in these geoecological functions. We can talk, for example, some of these geoecological functions, such as the carbonate growth, the production of sediments, okay, the cementation and lithification. And these are very important geoecological functions of coral reefs. And through this positive carbonate production, we need this symbiosis, especially for reef growth. Please follow next slide. But now we are on the Anthropocene era, okay, that we are have a fast change about the environmental conditions of the oceans, especially in the tropical coasts. Paulo, next slide. And it's very interesting to see that the environmental conditions are changing and driving the coral bleaching. That, of course, most of you know this process, and you have different conditions. For example, higher temperatures, the continental and urban runoff with increased pollution levels, some changes on the solar irradiation, and other processes, including microplastics, that are driving a higher frequency and intensity of bleaching events. Next slide, Paulo, please. And if you have persistent stress, of course, unfortunately, we have higher mortality levels of corals that are our trees in the marine animal forests. And maybe we need to change a little bit this concept of the professor, Mr. Simpson, in this slide. We have a changing environment. We are changing the optimal conditions that the traditional coral reefs evolved along the time to the suboptimal conditions. For example, please, Paulo, the clear waters are becoming more turbid with increased sediment levels. And this is a problem because the resuspension of sediments, for example, by the deforestation of the forests, the tropical forests, for example, here in Brazil, the Amazon forest, the Atlantic forest, is increasing the levels, the sediment levels, and the turbidity on the waters. The next, Paulo, the shallow conditions are also changing. Here you can see some example of the changing of the coastal development and runoff that is changing the sedimentation. Next, Paulo. The shallow, for example, the shallow environment that many of the coral reefs evolved is also changing by the sea level rise that is, of course, driven by the climate change. And next, Paulo, most of the coral reefs around the world will not have higher fast growth rates to track these rapid sea level rise. And next, Paulo, another change is in the oligotrophic waters. The oligotrophic water is also changing by the increasing of pollution. For example, in this very nice art in the PNAS, we can find the maximum mortality due to the dead zones, the lower levels of oxygen in the marine waters. Please, Paulo, the next. And the other very no change on the environment, of course, is the global warming that is changing the temperature range where the traditional coral reefs evolved. Please, Paulo, next. Not only the prolonged and long-lasting global warming, but also the marine heat waves that is increasing in frequency and intensity. And this is a very big problem to the conservation to coral reefs around the world. Please, Paulo, next. And maybe Professor Simpson may call the heat zone now in the Anthropocene. And this is a schematic overview of the marine animal forests, and we are changing. For example, the scleractinian corals that are the most important reef building species in the traditional coral reefs are changing for other groups. For example, please, Paulo, next slide. We have the rise of other organisms, such as the flesh macroalgae, the octocorals, for example, the zoantharians, and the sponges. Some species are thriving and increasing in many distinct traditional coral reefs around the world. Please, Paulo, next example. We can see on this article of the Professor Sergio Rossi that talk about the trophic ecology that Professor Giorgio Mancinelli, you talk a little bit in the next presentation. Please, Paulo, next slide. And we can see that the conditions are changing for the traditional coral reefs. But, however, we do not have only the traditional coral reefs. We have other reef ecosystems worldwide. For example, growing research in many seas worldwide are changing this reef paradigm that Professor Mr. Simpson taught to the students. For example, we have research in Caribbean Sea and Coral Triangle, Australia, South Atlantic, Red Sea, Northwestern Pacific, Kuroshio region, Mozambique, in the Persian Arabian Gulf, that is the hottest, the most hot sea in the world with higher natural temperature levels. Please, next slide, Professor Paulo, that are changing the paradigm. And we found around the world extreme coral reefs or marginal reefs that naturally occurring in these extreme conditions. For example, extreme temperatures. Turbid waters naturally occurring in turbid waters due to the suspension of sediments, energetic environment, the presence of the large rivers. And next, Paulo, other marginal reefs or extreme reefs, for example, extreme pH, places that naturally occurring extreme pH that is predicted due to the ocean acidification on the next decades, especially for traditional coral reefs. And also the mesophotic ecosystems, the mesophotic reefs, that are reefs that occur in a higher depth than the shallow water traditional coral reefs. Please, the next slide, Paulo. And how we can define the marginal reefs? Now, we can define the marginal reefs for two main assumptions. The first one, marginal reefs can be defined as marine entities developing in hard bottoms that survive under marginal or suboptimal conditions. Of course, this is a concept that considers the environmental conditions. The environment is the main aspect of this definition. Of course, this has been done for the terrestrial forests. For example, we have the dry lands, or the forests, for example, under higher precipitation. For example, the Amazonian forest. And the second definition is the marginal communities may also thrive on hard substrates, such as intertidal or subtidal rock reefs, even in estuarine habitats, and rhodolite beds that Professor Paulo work a lot on this research area. Please, the next, Professor Paulo. And this is a very, very interesting theme to study now about the marine animal forest. This is one of the chapters that we published on this book of the Professor Sérgio Rossi, edited with the Professor Lorenzo Bramanti. The next slide. In this map, we can see the occurrence of marginal reefs around the world. For example, the hot seas, the mesophotic environments, the reefs in upwelling zones, the high latitudinal reefs, and the turbid reefs. That, for example, in Brazil, we have the turbid zone that is naturally occurring in moderate turbid waters. Please, Paulo, next slide. This is a natural occurrence. In this slide, we can see a figure that was on the book chapter that we recently published. For example, we have the distinct environmental settings that drive the communities of mesophotic environments, the high temperature environments, the turbid, the upwelling, and even the high latitude reefs. For example, please, the next slide, Paulo. And, for example, one of these marginal reefs that is under a growing and intense debate around the world are the mesophotic coral ecosystems. In this article on the science of total environment, we agreed about the importance to conserve this kind of unique ecosystem. Please, next slide, Paulo. For example, this is the distribution of mesophotic coral ecosystems around the world. In this article, we mapped some of the points. We see that is a natural system that including occurring a lot here in the Western Atlantic, in the Caribbean Sea and Brazil. Next slide, Paulo. The mesophotic coral ecosystem naturally occurring between the depth between the 30 meters and 150 meters depth, we have this twilight zone where we have a decrease in the light levels. But we found scleractinians, for example, and other organisms that do the photosynthesis and support a higher biodiversity, including endemic species. Maybe Professor Hudson Pinheiro will talk to you about this system, that is a very good and nice expert in this kind of ecosystem. Please, Paulo, next. For example, this is a beautiful photograph from Joana Boavida in Portugal about a temperate mesophotic ecosystem in the coast of Portugal. Next slide, Paulo, please. But these ecosystems are under growing impacts. Usually we talk only about the impacts on the shallow water traditional coral reefs, but we are also, these kind of ecosystems are under increasing human pressure. And we have next slide, Paulo, please. In this article, we talk about the impacts and the conservation strategies here in the South Atlantic, in Brazil, also in Africa, and some of the oceanic islands. We cannot forget that this kind of ecosystems are under human pressures, such from the fishing activities, the invasive species, and also the climate change impacts. Next slide, Paulo, please. There is a growing research worldwide about not only the mesophotic coral ecosystems, but other marginal reefs, such as the vent sites and the E of this figure, mangrove systems with the presence of corals, the intertidal reefs, and other kind of the marginal reefs. Please, Paulo, next slide. For example, this is an example from my city, Fortaleza, in the northeast of Brazil, which we have naturally occurring turbidized reefs. I dive one day with the Professor Sergio Rossi, and it's a beautiful dive, and you can see sponge gardens. A sponge is one of the main important suspension feeder in this area. Please, the next slide, Professor Paulo.
Que é em Fortaleza também. Então, aqui você vê esponjas grandes, mas poucas espécies de corais. Uma que é uma espécie tolerante, que é it's covered coral, que é encontrada no Mar do Caribe, também no Atlântico Sul, e também uma espécie que é a Siderastre, que é específica de águas turvas. Então, são dois tipos de corais resistentes às condições subideais, como turbidez e suspensão de segmentos. Aqui você vê a proporção entre as esponjas e a Montracea cavernosa e algas também, canteiro de algas também, que são os principais componentes. E neste tipo, você encontra esponjas naturalmente ocorrendo em grande quantidade, neste tipo de zona de coral turvo. Este é um dos artigos que a gente publicou, que a gente fala sobre os recifes esquecidos, pois muitas vezes a gente esquece desses sistemas extremos e diferenciados. Então, por que precisamos estudar os corais marginais? Eu vou lhes dar 5 razões principais para estudar esse tipo de sistema. O primeiro, hoje, os corais marginais, eles podem oferecer insights sobre outros corais, como eles serão no futuro. Obviamente, não é algo comum no futuro, porém podemos encontrar aspectos interessantes nesses sistemas extremos de corais. A segunda razão é devido à diversidade única e ao seu endemismo, que realmente merece ser protegida por si. Nós encontramos nesses corais marginais altos níveis, pois eles se desenvolvem devido à seleção natural, selecionando espécies tolerantes e resistentes. O terceiro conceito de compreender é o papel potencial que os recifes marginais têm como refúgios universais, que é destacado nas pesquisas de conservação de recifes. Por exemplo, os sistemas mesofóticos estão sendo discutidos como sendo um refúgio para a mudança climática, um refúgio para os corais. A outra razão é devido ao conhecimento da estrutura, funcionamento e a resistência dos ecossistemas marinhos. Eles representam uma porção que não é muito analisada em relação à biodiversidade de corais em todos os mares. Não é tão estudada como os corais tradicionais na Grande Barreira de Corais, como a Grande Barreira de Corais na Austrália e no Mar do Caribe. Precisamos estudar mais sobre esses ecossistemas de corais mesofóticos e outros tipos de recifes marginais. E, finalmente, mais um motivo é que os recifes marginais, como esses de zonas turvas e de alta latitude e alta temperatura, eles são diferentes dos corais que existem em condições ideais. E muitos estudos no mundo inteiro mostram que essas funções da filogenética, a diversidade filogenética, são diferentes dos corais tradicionais. E é muito importante compreender e desenvolver a conservação desse tipo de sistema. Próximo, por favor. E nós encontramos duas características principais dos corais marginais. A primeira é a baixa riqueza de espécies, e a segunda é a dominância de espécies tolerantes a estresse. Essas características nos...
And develop the conservation strategies for this kind of systems. The next, Paulo. And we found two main core characteristics of the marginal reefs. The first one, the lower species richness. And the second, the dominance of stress-tolerant species. These characteristics lead to some concepts about the marginal reefs. Next, Paulo, please. And these reefs are now under the spotlight due to probably the resistance to marine heat waves. For example, we found now on the traditional coral reefs a lower resistance with higher bleaching rates and also higher mass mortality of corals. These usually occur in the optimal conditions in the shallow water traditional coral reefs. But on the marginal reefs, such as the two-zone reefs, the high latitude reefs, the high temperature reefs, and also on the mesophotic coral ecosystems, we found corals with a higher resistance and, of course, lower bleaching and lower coral mortality rates. And this is the main reason that these marginal reefs are under intense discussion around the world. Next, Paulo, please. For example, this is a kind of beautiful and nice Brazilian coral reef. Usually, we found fewer species, massive species, some endemic species. And for example, we have just one branching coral, and the fact is a hydrocoral, the Millepora, that is also known from the Caribbean Sea. This is a Brazilian reef. Is this the only branching coral that provided a structural complexity to this kind of environment? So, but in the last 2 years, we have higher mortality of this kind of the coral. Unfortunately, this is the only coral that suffer higher mortality rates after higher bleaching rates here in Brazil. And of course, if we lost this kind of coral, hydrocoral, in this case, Millepora, we lost its structural complexity of the reef, and with negative repercussions on the marine biodiversity, for example, on the reef fishes. The next, Paulo, please. This is the bathymetric distribution of the corals here in Brazil. We found a deeper bathymetric range, or in other words, these corals usually occur in deeper waters. We can see this on the schematic diagram on the next slide. Please, Paulo, again, the next slide. We can find distinct characteristics that Miguel Myers talked recently in one article. We found, for example, higher mortality and bleaching in the coral reefs of the Indo-Pacific and the Caribbean. But here on the South Atlantic, especially in Brazil, we found a distinct characteristic species, especially the massive corals with lower mortality rates after the bleaching events. Please, Paulo, the next slide. But these ecosystems are under pressure. How? And with problems in the conservation. For example, in the case of mesophotic coral ecosystem. The next slide, Paulo, please. We talk about a deep reef refuge hypothesis. So we think that the corals in the mesophotic ecosystems are more protected from the heat waves, from the sedimentation, from the solar irradiation, and protected from the fishing pressure. So this leads to a hypothesis that is called the refuge hypothesis. Please, the next, Paulo. But these kind of ecosystems, to act as a refuge site, we need to be protected. Of course, if this kind of ecosystems is under intense pressure, they do not act as a refuge for your own biodiversity and also for other reefs. For example, please, Paulo, please, the next slide. For example, the mesophotic ecosystems have some characteristics that increase their vulnerability to human impacts. And this is very interesting to understand. And moreover, more of these reefs are not recognized in the policy decisions or in the conservation strategies. And for example, most of the mesophotic ecosystems around the world are now not protected by the marine protected areas or the marine special planning. This is a huge problem. Or in other words, we need to expand our policies to protect this kind of marginal reefs. The next, Paulo, please.
Can you see the real?
No.
Rio de Janeiro, Brazil. I'm seeing here. Not with you?
I'm not seeing this slide.
Where is your slide? Where is this slide?
And on the article of Science of Total Environment.
Now we are in the gate 305. Not for you?
Yes, 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 the next slide. Now, okay, please, the next one.
Okay.
So I would like to finish my presentation on an idea, saying an idea that I published in this article alone. Hi, please, the next slide, Paulo. I felt like this guy alone against all woods to publish this article alone. Please, the next slide. The marginal reefs have one situation that is, I call it a marginal reef paradox. The cost of surviving in an extreme environment is lower diversity and also a limited three-dimensional structure. And we have resistant species. For example, resistant species to bleaching or to heat waves, for example, the warming. But these species evolved to specific suboptimal conditions, such as higher temperatures or higher turbidity, but not to all disturbance. This is important to understand. For example, we have species that is adapted to temperature, but if we have a higher sedimentation levels, that species will suffer many problems, for example, diseases or higher mortality rates. And these reefs have a problem because they usually have low ecological redundancy. And we have extreme environments. In these environments, of course, live very near the upper threshold. Or in other words, we found vulnerable reef systems. This is the paradox. We have some species that are resistant, but the system as a whole is very vulnerable to fast-changing environmental conditions. The next, Paulo. And this is the explanation about the resilience to global changes. The next one, please, Paulo. In this slide, we can see, okay, the situation. For example, we have marginal reefs in distinct places around the world under cumulative human pressure. For example, the places with red color or the orange color. The areas under higher human pressure. And unfortunately, these kind of ecosystems that is vulnerable are under intense human pressure, okay? So, in this case, we need to think more about this kind of ecosystems. Please, Paul, the next one. So, this kind of ecosystems is vulnerable. For example, I will give some examples very fast. For example, a mass bleaching of corals in a high latitude in Australia. Next, Paulo. Heat waves as a major threat to turbid coral reefs in Brazil. Next one, Paulo. I'm not the only one to think that these kind of marginal reefs are not climate change refuge. For example, mesophotic coral ecosystems are also threatened. The next one, Paulo. And interesting, these hot reefs in the Persian Arabian Gulf, we think that this kind of reef is more resistant, but we see on the recent results of this book chapter for the Professor John Burt, one very interesting result. Please, the next one, Paulo. See this result on the abstract. We have problems even with this kind of system, okay? And the next one, the final, okay, perfect, the next. So, the past slide, please, Paulo, not this. Yes, so this is the final slide, okay? We need to think. marginal coral reefs as climate change refuge. It's a kind of overselling. This is the question that I leave to the participants. So I talked too much, sorry. Thank you so much for the opportunity, and I'm very happy to be here. And now we go to the next talk. Thank you, Professor Paulo.
Thank you, Marcelo. It was great, man. A lot of brainstorm here in my mind. My brain is burning. Guys, please, again, put your brain to work, check your questions, and let's try to present more information. We are organizing all the questions. Professor Sergio, Carolina presented many questions, so we have questions already, but please, more and more, just because when we end all the presentations, then we will run all the discussions all together. So, Giovanna, who's the next?
I guess now is Professor Luis Kotovics. Luis, are you ready? I guess Luis.
Luis, are you with us?
Yes, sorry.
Wow, while Luis is uploading your presentation, Luis, just to advertise, we are having some problems with the transmission in Portuguese. So if you are in the channel in Portuguese, please, you can of course stay there, but move to the link that we explained in the chat there. So please pay attention. We have an access to that to you to be directly in the room of translation. Okay?
Paulo.
Yes.
Sorry.
I can listen to you, Giorgio.
I'm a little bit confused. When I'm expected to talk?
Well, you will be the next.
Right after Luis.
Or if you have problem with time, we can change. Up to Luis, of course.
For me, it's okay. If you want to change, for me, it's okay. We can change. Yes.
No. I will have problems in 1 hour, but I think that we will more or less be in time at 4:30 Italian time. So
well,
yes,
maybe.
in 1 hour I will necessarily leave.
Okay. Up to you, Luis.
What do you think is better to change? We can change, yes.
Okay.
Yes.
So let's change our mind. That's great. Let's do like that.
Um outro projeto, então eu vou ter que ir embora, Gi. Não se preocupe, por favor, obrigado por estar aqui, por ter falado. Por favor, então você, a palavra é sua. Posso introduzir o Jorge? Por favor. Enquanto o Jorge está se arrumando, por favor, apresente-o. Ok. O Dr. Jorge Mantinelli é um cientista italiano que tem um PhD em Ecologia da Universidade de Parma. Ele é pesquisador sênior da Universidade de Salento, igual ao professor Sérgio Rossi, e ele pesquisa as teias alimentares marinhas, focando na avaliação do impacto ecológico de crustáceos invasores. E ele também é o editor do Plus One, Relatórios Científicos e da Ciência Mediterrânea. Muito obrigado. Você consegue ver os slides? Está funcionando? Sim, mas não está na tela cheia. Certo, então... E agora? Mudou? Não.
No.
Okay, let's start again. Okay. Okay.
We can see your presentation, but it is still on.
Priest.
It is on the mode. It is on the mode of.
Does not move. Sorry, I don't know.
No.
It is on the mode. You see, and the PowerPoint mode. We can't see the full screen yet.
Unfortunately.
Giorgio, I have your presentation with me. If you wanna, I can.
Yeah, one last try, and then you will.
Okay.
You will take the floor. Okay.
Unfortunately.
And okay. What's it going on? Okay, now it should work. No,
Yeah.
it stays. It's freezed. I don't know. So, Paolo, please.
Oh, I'm so sorry. I think the thunderstorm of yesterday disturbed all of us, and also the internet here in south of Brazil.
But at the very end it moves. It's only extremely slow. Sorry.
I think that is the
Very
problem.
end it moves.
Okay, so
Please.
do you want to try again?
Yes, one last try. Sorry
Okay,
for
no worry.
being so problematic.
So,
Okay.
try again.
Okay. Okay. It works. But it does not present.
Interesting. Well, it's
Okay.
moving for us, but it's not in the full presentation mode.
Can you see it?
Yeah, but we are okay. If you prefer like that, we are seeing you see the first bars.
I don't know
of
why
PowerPoint.
it does not enter the full presentation mode. I don't know.
But if you prefer, present yourself like that. For me, it's fine. Just amplify
Okay,
a
take
little
the
bit
floor.
more.
Okay. Okay, you have my slides. Please start
Yes.
on your side.
Okay, so okay, let's do it. It's ready here. Can you see the presentation?
Yeah.
So
Yes.
the floor is yours.
Thank you so much. Thank you for the invitation. This is an extremely interesting and stimulating aspects for me. I'm actually working on something please, Paolo, next one, in a completely different field. The outline of my presentation is quite simple. I will make some general consideration on marine animal forests. Extremely incomplete, and please excuse my ignorance in the field, highlighting some open issue that, in my opinion, should be addressed somehow in future studies on marine animal forests. And I will conclude, but the main body of my presentation will be focused on the use of stable isotopes in ecological studies, and specifically for the study of functions in marine animal forests. Next one, please. Some definitions. At the cost of repeating what has been already said and mentioned, marine animal forests are communities dominated by sessile suspension feeders. These species are habitat forming. In other terms, they are ecological engineers, and they are able to change the local biotic and abiotic conditions in terms of light, currents, food availability, or why not the suspended sediment. All in all, they generate like a forest, like a tree forest, a three-dimensional architecture whose size, whose dimension can range from a few centimeters to meters. Moving from these general considerations and definitions, I simply want to highlight some extremely important functions that MAFs actually have. They do enhance the structural complexity and heterogeneity of the habitats where they occur. They promote local biodiversity, even though they are often dominated by a few species. In general, the general effect on biodiversity is positive. And last but not least, they control and modulate the availability of resources beside themselves to other species occurring in the forest. Next one. Only a few examples covering. I have grabbed photographs from every source.
De mangueirais, esponjas em mangueirais. E se quiser continuar, por favor. E aqui temos alguns exemplos peculiares nas profundidades do oceano, chegando na planície abissal, representado pelos montes marinhos e os campos de nódulos, e também eventos térmicos. Então, dentro dessa definição de florestas de animais marinhos, você consegue achar comunidades muito diferentes, localizadas em diferentes áreas, em diferentes profundidades, e sempre compartilhando as mesmas características. Eles criam novos habitats, eles agregam biomassa, e eles mudam as condições de biodiversidade do habitat ao redor. Desculpa. Tá. Eu tentei aqui resumir usando alguns exemplos de florestas de animais. Então, indo
the biodiversity conditions of the surrounding habitats. Next one. Sorry, there's been. So I made an attempt to summarize only using some examples of marine animal forests, so shifting from tropical coral reefs to oyster reefs to cold water coral reefs down to the abyssal plains and hydrothermal vents, and find some general variations in what may be abiotic conditions like temperature, light, also from the point of view of the functions, of the main functions that characterize the forests you are considering, moving from autotrophy to complete heterotrophy, with an extreme exception, autotrophy and hydrothermal vents. Next one, thank you. Oh. Sorry?
I guess Paulo is off. No, he's here. I don't know what happened. Paulo, can you hear us?
Sorry, guys, I dropped here. I lost my connection. I was here, and in 1 second I wasn't anymore. Okay, let's start. Sorry, guys. Let's start again. Today's another hard day for all of us. Are you okay,
So,
Sergio?
yeah,
Giorgio,
I'm okay.
is fine? The slide is right? Is this right?
Yeah. Only, I mean, to get into the detail of what the conclusion of what I was mentioning. So, in terms of functioning, you may actually observe a gradient, as long as I'm generalizing and I'm simplifying what is absolutely complex. But in practical terms, you may observe, depending on the availability of light and accordingly related with depth, a shift from autotrophy to heterotrophy. A specific aspect, an extremely interesting aspect, is that as long as you have shallow water forests, you have autotrophy dominating, also because of the evolutionary and morphological adaptations that the whole communities have experienced, and to the development of symbiotic interactions with primary producers. Obviously, as long as you increase the depth, light fades, heterotrophy dominates, but as long as you reach hydrothermal vents, you have again autotrophy in terms of chemautotrophy. So chemical compounds like and so on can be used by primary producers. Next one. This is a sort of
organismos que regulam o funcionamento de uma forma troficamente simples. Outra generalização é que as florestas de animais marinhos são sumidouros de carbono, mas o resto da apresentação vai mostrar mais aspectos dessa questão aqui dos sumidouros. Mas do ponto de vista prático, se nós considerarmos apenas os organismos que se alimentam de suspensão, nós conseguimos ver que, se entrarmos nos detalhes das dimensões do que é filtrado pelas esponjas, poliquetos, etc., você vê que há uma mudança. Então, mesmo se considerarmos sempre os mesmos alimentos, você vai encontrar uma variação incrível em termos do tamanho do alimento que é ingerido. Mas isso é apenas um exemplo. Vamos continuar? Então, voltando aos exemplos que eu mostrei no começo da apresentação, a pergunta geral que surge é: há um padrão geral que conecta, ou uma regra geral que pode ser identificada ou enfatizada, que associa a complexidade do habitat formado pelas florestas de animais marinhos, a biodiversidade que caracteriza essas florestas e como eles funcionam em termos de transferência de energia, de nutrientes. A segunda pergunta: quais ferramentas podemos usar para estudar a transferência e o fluxo de energia e nutrientes, não apenas o carbono, mas outros nutrientes nessas florestas. Apesar de estarmos focando nos corais e habitats específicos, será que existem ferramentas gerais para todos os ecossistemas? E a terceira pergunta é: qual a contribuição das interações simbióticas para regular a matéria e a energia nessas florestas? Próximo slide. Bem, isso aqui é um bom assunto para um artigo de revisão. Eu fiz uma meta-análise de todos os estudos que já foram realizados no passado usando os isótopos estáveis nessas florestas. Eu preciso admitir que encontrei alguns problemas, pois esse termo de floresta de animais marinhos...
For a review article, I made a sort of meta-analysis of all the studies that have been performed in the past using stable isotopes on marine animal forests. I have to admit I've encountered some problems because marine animal forests as a term is in use only, let's say, since the last 5 years. Please correct me. So you need to get into the detail of each typology. So repeat your search, and what you may find is that there is a great heterogeneity in the use of stable isotopes for the study of marine animal forests. The last one, and the most appealing, at least for me, is the one that is shown in the slide. If you manage to highlight the graph, please go on. Okay. This is what has been found in a hydrothermal vent in the community in an animal forest, characterizing an hydrothermal vent. I will get into the details of what is shown in the graph, but in practical terms, what I found extremely appealing was that using stable isotopes, the analysis of stable isotopes, the authors were able to identify quite a huge set of different trophofunctional groups within the community. So what it may be considered as extremely simple, as a matter of fact, it is not. And this is the example with the hydrothermal vent from the Gulf of Guinea, but there are many other examples with oyster reefs, even coral reefs, a little bit less, and so on. So let's get into the detail of the method. Some definitions again. So isotopes are atoms with of the same element, but with the same number of protons, but with a different number of neutrons. Specifically in ecology, stable isotopes are used, so they do not undergo radioactive decay. And please go on. Even though almost any element has got stable isotopes, in practical terms, the most popular in ecology are carbon and nitrogen, and to a lesser extent sulfur, but I will get back to this later on. Please go on. Well, in practical terms, if you want to measure the concentration of different stable isotopes of the same element in a sample, all you have to do, this is a general, a simplified diagram a mass spectrometer, all you have to do, all in all, is to burn your sample, transform it into a gaseous form, and using a carrier, generally it's helium. Well, you separate within a magnetic field the different isotopes of the element. This is to say that even though extremely similar, only differing by one neutron or two at last, well, they do behave under certain conditions. They do behave differently. This is the basis of the methodology. But if please go to the next one, please. Yeah, maybe I've shifted something. Could you please get back? No. So no problems. Let's go on. Next one. Okay. So, no, too much.
I think we have this delay from Italy and south of Brazil.
Yeah. So they do behave differently in a magnetic field, but most importantly, they do behave differently in the environment. This is a classical example with water. Depending on the fact that you have the lighter or the heavier isotope, you have a different chemical physical behavior of the molecule. Please go on. No, there are some, sorry, but there are some shifts in the, okay, thanks. In the biota, isotopes are characterized by the phenomenon of fractionation. So a relative partitioning of the heavier and lighter isotope between different phases in a system. In practice, you have a change in the ratio of carbon isotopes, nitrogen isotopes, as they move along a food chain or throughout an environment. The fractionation value of factor identified in terms of delta values is simply estimated by the difference of what you measure in terms of isotopic ratio in the consumer and its source. The underlying mechanism are today still under consideration. I mean, it's not totally clear how it works, the whole story, but what is clear is that as long as you have a series of physiological processes, in particular excretion, you have a preference for isotopically light isotopes. So, on the other hand, assimilation and fixation in tissues preferentially determine an increase in the heavier isotope. Next one, please. So, okay. Yeah. So for nitrogen, in general, you observe a fractionation value between 3.2 and 3.4 per mil. For carbon, you don't have this, let's say, general response that are more heterogeneous, but in general, carbon is considered to be extremely conservative in terms of fractionation. So the general value that is in use is between 0 and 0.5. Accordingly, the isotopes of nitrogen can be used to investigate the trophic structure of a community or an assemblage, while carbon isotopes, they do highlight which are the sources of carbon. In conclusion, we have an example of how it can be used, fractionation, for example, for calculating the trophic position of a consumer. Comparing the signature of the consumer itself with a baseline, and considering the fractionation of 3.4 plus the trophic level of the baseline species that you have in use. So 1 if you have a primary producer, 2 if it is a primary consumer, and so on. Next one. Have a look